How's it going? This is Mr. Murray coming to you with a video on changing forms of quadratics. I'm calling this Changing Forms of Quadratics 2. Now in this video I'm going to be giving you guys a few more examples based off of the previous video. If you haven't seen that, I'm going to go ahead and link to that video right now. So it should be coming up top. And that video was focusing on how to go from what we call factored or intercept form into standard form, ax squared plus bx plus c. That's the general idea. Now, I do have a utility to expand out will not fail that I encourage you to check out. And again, I would seek out the lesson notes because that's been something I've kind of assigned over the past couple days. All right, but what we learned is the big idea behind how you do this has to do with distribution. And the idea that you're just going from distributing one thing like you might have seen before to now distributing just a couple of things. And the way we made this a little bit more user-friendly is through the process of the box method or area method. So in the area method, we took one of the terms, we call it one of the pieces, and put it up top. The other piece we put on the side. And then we just basically calculated each of these four little areas one at a time using the length times the width. And then we added them all up and combined like terms to get the final answer. If there was an a value that wasn't 1, in this case it was 1, we would have to multiply through as a last step. And that's something that you'll again see in this video. All right, so let's get started with an example of t plus 4 and t minus 9. So as you can see, I'm already starting to build my box. So I'm going to do t plus 4. I'm going to do t minus 9. And let's start to calculate the areas. So I've got t times t. That's t squared, right? T times itself. 4 times t. That's 4t. Negative 9 times t. That's negative 9t. Negative 9 times 4. That's negative 36. So I add up. I've got t squared. This is negative 9 plus 4 is negative 5t, and you're allowed to use a calculator, including Google Calc or Desmos or Wolfram, minus 36. Okay? So please make sure you understood this. If you need to rewind, go ahead and do that. And then in a moment, I'll show you just another example. All right, now I'm going to spice it up a little bit, and I'm just going to put a 3 up front. So remember, to start, we build out our box. We do up top g plus 6, g minus 4. Probably make your g's loopy so they don't look like 9s. G times g is g squared. G times 6 is 6g. G times negative 4 is negative 4g. Negative 6 times negative 4 rather is negative 24. We can see that these are going to combine and make 2g, 6 minus 4. So I've got 3 times g squared plus 2g minus 24. And then the last step we actually need to do this is to distribute in the 3. So I've got 3g squared plus 6g minus 72. All right, so again, please make sure you understood what I did here. If you need to go back and rewind, please feel free to do so. And then in a moment, I will move on to another problem. All right, here's one for us to do together. You can see the coefficients are a little bit big. So what am I going to do first? First, I'm going to build that box. Build me a box, a 2x2 box, and it's 2x2 by the way, because there are 2 terms here, and there's 2 terms here. So up top, what do I put? Q plus 14. You could do Q minus 19, but regardless of what you do, you put the other one down here. So either this is Q minus 19 and Q plus 14, or vice versa. So now I multiply Q times Q, that's Q squared. Q times 14, 14Q. Q times negative 19, negative 19Q. Negative 19 times 14. So this is the one place where you're probably going to want to have access to a calculator to do these ones out. if you can do 19 times 14 in your head, that's great. It's like basically 14 times 20, which would be 280, minus 14, and that would be 266. That's another way to think about it. Like, it's almost 2014s, but it's like one less. Okay, combining like terms, I've got q squared. I add these, I get minus 5q. And then I get minus, sorry, this needs to be a minus because it's a positive times a negative, negative 266. So again, look at the patterns here. These numbers have to multiply to C, and they have to add to B. So things to think about, because again, eventually, I'm not going to give you I'm going to give you this, and I want you to go the other way. Okay? Now I'm going to go into a couple you tries. So here's what I want you to do. I want you to take a moment. I want you to pause the video. I want you to try to do this one out on your own. And then when you're ready, unpause, and I'll show you what I got. All right. So here I go. Up top, q plus 8. To the left, q plus 20. In the box, q squared, 8q, 20q, 160. Okay, so I get q squared plus 28q. Don't forget to add up those q's, plus 160. Q squared plus, make sure you get 28q plus 160. Okay, just setting up our box and doing it step by step. Last you try here, I'm throwing in a GCF. So again, as with before, take a moment. Please think carefully about the process, expand it, put it into standard form, and then when you're ready, unpause, and you can see what I got. All right, so remember, the first thing we're going to work on is we're going to work on the g minus 10 and the g plus 5. So let's do it. G minus 10, g plus 5. I'm going to change colors to get creative here. So g times g, g squared, g times negative 10, negative 10g, g times 5, 5g, 5 times negative 10, negative 50, right? And remember, each of these, this is just area, right? I'm breaking it down by area. So I've got 5, I keep that because the a is not 1, and I get g squared minus 5g minus 50, and then I need to distribute the 5, so I get 5g squared minus 25g minus 250. Alright, so hopefully you found this video to be helpful. I know that the expanding is not an easy concept, so that's why we'll have a couple days to work at it, and we'll likely talk about it on the Hangout. Please feel free to continue to work on this. I really encourage it. Work hard on this. You know, go past what you need to go by on the website. Remember, we have the practice at expand.willnot.fail. And remember, you can do it. All right, thanks for watching. Have a wonderful day, and don't forget to love math.